What's up? This is still the great teacher Alcantara here with another video, and this time around we're gonna talk about none other than independent and dependent variables. Let's just jump right into it. For this video, our target is first to distinguish dependent from independent variables, and then at the same time continue our practice with finding the domain and the range of a given function. If last time what we did with relations and functions is that we took note of the values or the elements for the domain and the range and put it in set notation, this time around we will practice an advanced concept that we will do for our next lesson, which is about table of values. So we will be given a domain, and then we will try to figure out what range will fit that certain function. At the same time, again, we're going to practice in distinguishing what makes a dependent and what makes an independent variable. So let's start with a few concepts that are true to real life. Let's say that we have the following examples. For this certain part, I will just simply give out the answers because, again, I just want you to understand that identifying dependent and independent variables is something that we can relate to the concept of cause and effect, something like that. Basically, the cause will be the independent variable, and then the effect will be the dependent variable. So basically, what I'm trying to say is that these two words or these two concepts, you know what it means without overthinking it. It's just that what is it in line with mathematics? So later we will figure that out. So first, let's say that we have the following. It says that this first situation that it costs 750 pesos for an album of mainstream artists. So it's like an estimate. So the situation gives us this. The more albums I buy, the more money I spend. So our goal is to identify which is which. So we could say that the more albums I buy is in line with our independent variable. As you can see, the color coding there. The reason why this is our independent, because the number of albums that you're gonna buy is not gonna change. It depends on your decision. But the more money you spend, or the money that you need to prepare, depends on the album that you're gonna buy. Like for example, me, I decided to buy 5 albums. Well, I have to prepare more money for that. Then I'm like, within now that I'm in the cashier register, I'm like, oh yeah, I have a change of heart. Well, the money that you're gonna prepare will lessen depending on the change of heart. Or you're gonna 3 albums instead of 5 or something like that. So that's what I'm trying to say. It's not that difficult to identify. And later, you will notice that there's sort of a pattern in real life as to what is always or most of the time is the dependent, and with what is most of the time the independent. So later we'll figure that out. Next, let's say that we have here, Bruce is organizing an online concert event to help raise money for communities affected by the pandemic. So the more tickets sold for the concert, the more money will be raised for charity. So we can say here immediately that the more tickets sold for the concert will be our independent, and the more money will be raised for charity is the dependent. As you can notice with our first 2 examples, it's the money that is our dependent variable based on the situation. So it's not the tickets that is depending on the money. It's the money that is depending on the amount of tickets that will be sold. Okay? I hope that makes that clear. Next, now we have Rose, who's having her virtual birthday party. She wants to prepare 3 cupcakes to deliver for each friend she will invite. So the independent variable here, again, is the friends, and then the cupcakes is the dependent. So the reason for that is because you are preparing cupcakes based on the number of friends that you will invite. It's not that you're gonna prepare cupcakes and it depends on and it's independent of it. No, because that's a bit counterproductive and not cost efficient. Because if you prepare tons of cupcakes and only a few people will come, then it might not be eaten, it might get spoiled, it might be a waste of money or something like that. So that's how it works. Situation 4, Luigi is playing the classic Super Mario game, and the more blocks he hit, the more coins or power-ups he can get. So here, the independent variable is the more blocks to be hit, and then the same time, the coins and the power-ups is the dependent. The reason for that is because if you don't hit any blocks at all, you're not gonna get any coin or power-up. So it depends on the amount of blocks that you will try to hit, the more coins or power-ups that will arrive to you. That's how it works. And lastly, um, at the end of the level in the Super Mario game, the higher he reaches in the flagpole, the higher his score will be. So just like the money thing, the score is something kind of similar. So the score depends on the height of the jump that the character will take. So that's your independent variable, the jump, the height, while the score depends on it. So again, if you play the Super Mario game, I know it's pretty old and you guys are pretty young, but at the end, as you can see in the GIF on the side, or the GIF, well, if you jump, then the higher it is, the higher the score. To put it in perspective, in mathematics and somewhat in science or whatever subject, this is how they describe dependent and independent variables. First thing, dependent variables or variable is characterized as the variable whose quality depends on the estimation of another variable. So that's why it's called dependent. It depends on something else. While independent is a variable whose values are independent of changes. It's not like you're gonna change the amount of albums that you decided to buy even if you have more money. That's not how it works. The money changes, the amount of money you prepare changes depending on the albums you wish to buy. It's something like that. That's why we have to emphasize the difference between the two. And to fully put into perspective, we're gonna use the examples that we had and put it in quote unquote word problem. And let's have this first situation. Let's call it my Boodle story, something that is maybe based on real life events. Who knows? So Patrick is considering to collect albums to display in his renovated room. If one album is 750, how much does he need to prepare to buy 5 albums? So here, the first thing that we have to identify is which is the independent and which one is the dependent variable. So the independent here is the number of albums, and then the dependent is the amount that he needs to prepare. As you can notice on your screens, we are already taking note and jumping right into it so that you guys will get used to it and understand that the independent variable in mathematics, we use the variable x, and then the dependent variable, we use the variable y. The reason why we're putting it out there as early as now, so that you're not gonna get confused with it. So that we'll be able to not only identify points, solve for values, but at the same time find out equations, which is again an advanced concept, but at the same time trying to hit more birds with just like one stone. Is that how the quotation works? Anyway, so let's say that we have a table of values. Even if you don't know how this one works yet, you can already understand it. So basically here in the set of values, you start with the number of albums. Let's say you have 1 album. You simply want to figure out how much you need to prepare. So you don't have to panic because there's a pattern in this. And you can simply look at the given word problem. So we can say that 1 album is worth 750. So 1 album is 750. Then if you buy 2 albums, you'll simply multiply it by 2. You'll get 1,500 for that. And then if you need 3, that will be 2,250. And then if it's 4, it's 3,000. And if it's 5, it's 3,750. So what we're trying to figure out here is that there, I guess, is a pattern. And if we make use of variable as representation, so the amount is y, and it's equal to something in relation to x, which is the independent variable. So we could start always with that, which is y is equal to x. Y is the amount based on the word problem, and x is the number of albums. But when we're writing that equation, there is still something missing. It's not just y is equal to x, because it's not equal. 1 is not equal to 750. So as you can notice, the pattern that we found is that we're multiplying 750 to the number of albums. So with that being said, the equation that we can form is as simple as y is equal to 750x. Again, y is your dependent variable, which is about the amount. So that's how it works. Why are we multiplying 750 to x? Because the x is the independent variable in line with the number of albums. So if you substitute 1 to x, that will be 750 times 1. The answer is 750. So that's correct. That's the amount that you need to prepare. And so on and so forth. That's how it works. And in this case, you can write ordered pairs here like 1, 750, 2, 1,500, 3, 2,250, 4, 3,000, 5, 3,750. So those ordered pairs can be graphed on the rectangular coordinate system, and you can form a line with that, which is our lesson in the future. I'm just giving it a heads up so that you guys can understand that these concepts are connected with one another. Let's continue with our next word problem. Let's say that we have Ticks for Peeps. Bruce is organizing an online concert event to help raise money for communities affected by the pandemic. How many tickets does he need to sell to raise 2,000 pesos? So which of the following is the independent variable? Which one is the dependent? Our independent again here is the tickets, and the dependent is the money that will be raised. So again, let's try to complete a table. In this case, again, it's noted there that one ticket is 100 pesos. So if you sold one, you'll get 100. Sold two, you get 200. 3, 300. 4, 400. And if you get 5 sold, that will be 500. So in that case, just like earlier, the pattern that we can find is that we can use the equation y is equal to x. But what do we need to put before the x? Or what do we multiply to x? In this case, if earlier it's 750, now we're going to multiply 100 instead. The reason for that is because x is represented by tickets. So for every ticket, you simply multiply that to 100. So that's how it works. So the question there is, how many tickets does he need to sell to raise 2,000 pesos? So this concept is an additional question for you to figure out how equations work. So using the equation, you will simply substitute 2,000 to y and then equate that to 100x. Divide both sides 100 and you'll get x is equal to 20. Some of you guys might say, sir, do I really have to do it that way? The answer is yes, because it's a practice of different skills such as substitution and the properties of equality. But some of you guys might be able to answer this without using that and just simply by the patterns. So far, it's okay because that's not yet the specific learning target or objective, but in the future, you have to do it the step-by-step way. And with that said, let's go with situation 3. Take a cupcake. So for Rose's virtual birthday party, she wants to prepare 3 cupcakes to deliver for each friend she will invite. So here, again, we have explained earlier that our independent variable is the number of friends and the dependent variable is the number of cupcakes that she needs to prepare. So in this case, again, we have a table. So for number of friends, 1 friend, you'll have to prepare 3 cupcakes. 2 friends, you'll have to prepare 6 cupcakes. 3 friends, you have to prepare 9 cupcakes. 4, you have to prepare 12 cupcakes. And then 5, you have to prepare 15 cupcakes. And again, just like earlier, there's a certain number that we multiply to x. Earlier, it was 750, 100. This time around, we're multiplying 3. Because 3 cupcakes for each friend. So that's our answer. Y is equal to 3x. Let's go with our fourth example. This time around, the collector. So Luigi is playing the classic Super Mario game. How many blocks does he need to hit to get 20 coins or power-ups? So again, the independent variable here is the number of blocks, and the dependent is the coins or power-ups you will get. At the same time, to complete the table, 1 block is equal to how many coins or power-ups? Exactly 1. Same case, 2 is to 2, 3 is to 3, 4 is to 4, and 5 is to 5. The reason behind this is because if you play the game, if you hit a block once, you'll get 1 thing. Whether it's 1 coin, 10 coin, or 1 star, or 1 flower, or whatever it may be. There's an exact thing that you're gonna get once. Okay, depending on the game though. Some cases, there are outliers wherein you'll get more than just 1 coin or whatever it may be. But this thing right here, unlike other equations, this one is, I think, much more common sense. Since 1 is to 1 here, we can say that the equation is as simple as y is equal to x. Because for every block, you can get a possibility of either 1 coin or 1 power-up. Okay? And then lastly, situation number 5. I'm on the next level here. So Luigi reached the end of a level in the Super Mario game. And the question is, how high should he reach to get 5,000 points? So it is noted here that 1 feet is equal to 625 points. So again, our independent variable here is the jump.
the height of it, and then the dependent is the points that he will get. So the height of the jump, let's say that the height is 1 feet. So based on the detail in the word problem, that's worth 625 points. 2 feet, that's going to give you 1,250. 3 feet, that's going to give you 1,875. 4, that's going to give you 2.5. Then 5, that's going to give you 3,125. So in here, we can notice that we're multiplying 625 for the height of the jump. So in that case, it will be 625x. So the equation is, again, y is equal to 625x. And to answer the word problem, the same case, you're simply substituting the 5,000 points to y. So that will be 5,000 is equal to 625x. Apply the division property of equality, divide both sides by 625, and the answer there is 8. So for 8 feet, you're going to be able to get 5,000 points. So that's how dependent and independent variables work. Not only does it help us identify what is the x variable and the y variable, it also can lead us in the concept of table of values, linear equations, graphing, and so on and so forth. So that's how we will bridge the gap between this lesson from relations and functions to our focus for this term, which is linear functions, or LETV. And that will be our next lesson. For the time being, that's it for dependent and independent variables.
Well, that ends this video lesson, and I hope you learned something new, or you were able to somewhat refresh your memory with things, and I hope this helps out. If you have more questions for clarification, you may maximize the chat box below. Let's just pretend that I'm actually a YouTuber who will comment or reply to messages in the comments. Who knows? Maybe I will. Maybe I won't. Who knows? But hope you guys learned a lot from these videos. And I hope you are doing well. And you are able to rest. At the same time, you're not panicking. Just keep on learning. And hopefully, math will go right with you. Because at the end of the day, mathematics is for everyone. Everyone is a math person. Hashtag I am a math person. I'll see you guys. Always remember what's up. That's respect.